All right, so we left off, I believe, on number 89. In my part 2 video for this final exam review questions, I finished 89A, which you see written right here. So I've gone ahead and I copied down B, this system of nonlinear equations, which is x squared minus 3y squared equal to negative 1, and 2x squared minus 7y squared equal to negative 5. Since the x's are squared on both of these equations, and the y's also happen to be squared, so these work out nicely for elimination. These are like terms. I'm going to choose to cancel out the x's. In order for me to cancel out the x's, I'm going to have to multiply the top equation by a negative 2. So I'm going to go ahead and put some parentheses here. I'm going to distribute this negative 2 to each one of these terms. Oops, messed up there. Got to go to the negative 1 there. Good. And then I'm going to add it to this second equation. I forgot to write the x squared there. Please don't forget to write x squared. I do remember to write it in shortly later. I narrate my videos afterwards. That's why I caught this later on. Alright, so we're distributing the negative 2 for that top equation. So we're going to end up with negative 2x squared plus 6y squared equal to 2. Second equation is going to stay the same. This is where I caught my mistake that I forgot to write in the squared. So I did write that in, x squared. Alright, so now we can add these two equations together. The x squared terms are going to cancel out nicely because negative 2x squared cancels out with positive 2x squared. We're left with a negative y squared is equal to a negative 3. I'm going to divide both sides by a negative 1 in order to get rid of the negative in front of the y squared. And here we are going to end up with y squared is equal to 3. I'm going to use the square root property in order to find the solution for y. So we're going to take the square root of both sides. Take the square root of y squared. Remember, when we take the square root of this side, we need to add there a plus and minus. So it's going to be plus or minus square root of 3. So y is equal to plus or minus the square root of 3. Now we're going to take remember this is two values. This isn't just one value, but this is actually two values of y. We're going to substitute both of these values back into either one of the two equations. I think the top equation is a little more simpler than the bottom one. So that's the one I'm going to choose to substitute for. But you could choose either one. So we're going to substitute. We'll start off first with y equal to negative square root of 3. And I'm going to choose once again the top equation, the x squared minus 3y squared equal to negative 1. Every time I see a y in that equation, I'm going to substitute negative square root of 3. Okay, now we can simplify this. Let's see. Negative square root of 3 squared that's just going to give me a positive 3. And then we're going to have negative 3 here times 3 is going to give me minus 9. I'm going to add 9 to both sides to isolate the x squared term. And we'll end up with x squared is equal to 8. Once again, I'm going to use the square root property. So I'm going to take the square root of both sides, square root of x squared, and remember, let's put plus or minus square root of 8. I'm going to simplify this a little bit. The square root of 8, I can factor out 8 into 2 times 4, and 4 is 2 times 2. So there is a perfect square in there that I can take out of the root. So x is actually going to be equal to plus or minus 2 square roots of 2. All right. What we actually have found here is we actually have found two ordered pairs. I'm going to write down those two ordered pairs so you can actually see what it would look like written out. So one ordered pair is going to be negative 2 square roots of 2, comma, negative square root of 3. And the other ordered pair is going to be positive 2 square roots of 2, comma, negative square root of 3. So if any of you are looking at this and you're wondering, how did we get two ordered pairs? Remember that plus or minus 2 square roots of 2 represents two answers. So these are your two x values that we got here. And remember that we substituted y equal to negative square root of 3, so that's how we got that y value for those two ordered pairs. So we're not done with this problem, even though we did a lot of work here. Remember that y was originally here equal to negative square root of 3 here, and also positive square root of 3. I've only substituted the negative square root of 3. I still need to substitute positive square root of 3. So we still have a little bit more work to do. So now let's go to this second part here. We're going to substitute positive square root of 3. And I'm going to use that same equation that I did last time. Okay, we're going to substitute y equals positive square root of 3. And like I said, I'm just going to choose to use the same exact equation I used last time. The x squared minus 3y squared is equal to negative 1. Every time I see a y in the equation, I'm going to write radical 3, or square root of 3. Alright, so now we're going to have here x squared minus 3 times square root of 3 raised to the second power equal to negative 1. So if we square the square root of 3, that's just going to give me 3. And then if we multiply this here. It's like negative 3 times 3. That's going to give me minus 9 equal to negative 1. I'm going to add 9 to both sides to isolate the x squared term. And that's going to give me x squared is equal to 8. And once again, I use the square root property. Square root both sides. Square root the x squared. When I square root the 8, remember to put plus or minus square root of 8. I can simplify 8. So I can see here that the square root of 8 is the same thing as 2 square roots of 2. So I'm going to write plus or minus 2 square roots of 2. And now I'm going to write my two ordered pairs. Negative 2 square roots of 2 and positive 2 square roots of 2. So once again, here are my ordered pairs now. Negative 2 square root of 2, comma, square root of 3. And then here we're going to have positive 2 square root of 2, comma, square root of 3. I'm going to go ahead and write down the two ordered pairs that we had found previously right here so that I can have all of my answers together. Remember, they were up here in the work we had done previously. I'm just going to copy them down below the two ordered pairs that I just wrote down. So we had negative 2 square root of 2, comma, negative square root of 3. And we also had positive 2 square root of 2, comma, negative square root of 3. And it looks like I forgot the negative right there. So if you could please write in the negative, that would be great. I forgot the negative on the square root of 3 on that last ordered pair. Just forgot it. Write it in. All right. This next problem here is part C for that same number that we were working on. Once again, we're working with the system of nonlinear equations. Here it looks like we have one parabola and one linear equation here, one line. I'm going to use elimination. I'm going to eliminate the y's. So I'm going to multiply the second equation by negative 1. So now when we add these two equations up, the y's will immediately cancel out. And we will be left with 0 is equal to x squared plus 4x plus 4. I'm going to factor this out. This is a perfect square trinomial. It factors out into x plus 2 times x plus 2. Since I have the same factor here written twice, I don't need to set both of these factors equal to 0. I could just set one of them equal to 0 because it's going to give me the same solution. So I'm going to get x is equal to a negative 2. Now we're going to take this and we're going to substitute it back in. And once again, it doesn't matter which one of the two equations you use because you'll end up with the same exact answer. I'm just going to choose to use the top equation, y equal to x squared minus 1. So I'm going to get y is equal to negative 2 squared minus 1, which is equal to y is equal to 4 minus 1, which is y equals 3. So my ordered pair is going to be negative 2 comma 3. And it seems like it's a miracle here. I didn't make any mistakes here. I didn't forget anything on this one. Wow, that's amazing.